All right, if you've spent your time mastering stocks and bonds, you've really built a solid foundation. But today we're going up a level. We're talking about the architecture of leverage itself. This is where we stop thinking about just owning things and start talking about sophisticated control.
John, it's time to move beyond simple ownership and talk about the leverage of options. Owning a stock gives you that one-to-one exposure. Stock goes up, you make $1. That's fine. It's a great start. But to really start architecting a portfolio, we need tools that are way more sophisticated.
I couldn't agree more, Steve. And that's where so many people get it wrong. They hear the word options and they immediately think gambling. They think it's like putting it all on red at the casino. And that is a huge, huge misunderstanding. Because if you understand the math, if you get the structure, it's actually the ultimate tool for controlling risk and amplifying your returns. It's all about precision. It's not about chance at all.
Exactly. So that's the plan for today. We're going to deconstruct this whole machine. We'll kick things off with why we even need to move beyond simple ownership. Then we're going to get into the nuts and bolts, the architecture of the contract itself. We'll cover the two basic directions, you got calls and puts, and the two things that make them tick, price and time. And then we'll put it all together and see that leverage multiplier in action. Let's dive in.
So Section 1, beyond simple ownership. Look, owning a stock, like I said, is linear. It goes up $1, you make $1. Goes down, you lose $1. Simple. But options introduce what we call non-linear outcomes. They let you sculpt your exposure, to put a hard limit on your risk, and to make your capital work so much harder in ways that you can't do with stock alone. It's really the difference between being a passenger in the market and actually getting in the pilot seat.
So, if we're going to pilot this thing, we need to understand the controls, right? That brings us to Section 2, the options contract architecture. See, an option isn't a piece of a company. It's a contract. It's a legal agreement. It gives you rights, but, and this is key, no obligations. Every single detail inside that contract has a very precise mathematical and strategic purpose.
And the first, and I mean the absolute most critical component you have to get, is this number, 100. Every single standard options contract in the U.S. market represents control over 100 shares of the stock. That's it. It's not up for debate, it's the universal standard. So when you see a price quote for one contract, you're always talking about a 100-share block. This right here, this is the source code of leverage.
Right. Now to get that control, you don't fork over the money for all 100 shares. No way. Instead, you pay something called the premium. The easiest way to think about the premium is it's the price of the contract itself. It's just a fraction of what the actual stock would cost, and this is a game changer for risk management. It is the absolute most money you can possibly lose when you buy an option. So you could control, say, $50,000 worth of stock for a premium of maybe $2,000, and your total risk is capped at that $2,000. That's what we mean by capital efficiency.
Right. So you've got this contract. It controls 100 shares, and you've paid your premium for it. But what right did you actually buy? What can you do with it? Well, that brings us to Section 3, the two directions. An option lets you make a bet on where the stock is headed, either up or down. And the two instruments for that are the call and the put.
Okay, over on the left, we have call options. A call gives you the right, but not the obligation, to buy 100 shares of a stock at a price you've already agreed on. It's a fundamentally bullish bet. You buy a call when you think that stock is going to go up, maybe way up.
And on the flip side, you've got the put option. It's the exact inverse. A put gives you the right, but not the obligation, to sell 100 shares at a pre-agreed price. Now, you can use this to make a bearish bet, right? You profit if the stock tanks. Or, and this is really where it gets strategic, you can use it like an insurance policy on stock you already own. If your stock position drops in value, the value of your put goes up, and it helps cancel out that loss. It's a pure risk management machine.
All right, so we've got our direction figured out. We're bullish with a call, or we're bearish with a put. But the contract needs more details. This brings us to the two most crucial variables that define its entire existence: price and time. These are like the coordinates on a map that determine a contract's value and its lifespan. They're the main inputs into how that premium gets calculated.
The first variable is the strike price. This is that pre-agreed price we keep talking about. It is locked in, it is set in stone for the entire life of the contract. So, let's say I buy a call option on XYZ stock with a $150 strike price. That means I have the legal right to buy 100 shares of XYZ for exactly $150 a share anytime before that contract expires. It doesn't matter if the stock's market price goes to the moon, 200, 250. My purchase price is locked at 150. And that difference, that's my potential profit.
And this is such a critical difference from just owning stock, that right you bought isn't forever. It exists on a ticking clock, and that clock is governed by the expiration date. Every single option has a finite life. Could be a few weeks, could be months, could even be a couple years out. But on that specific date, the contract is done. It's void. It ceases to exist. This brings in this brutal concept called time decay. The fancy term for it is theta. And all it means is that every single day that passes, your option loses a tiny bit of value, just because there's one less day for your bet to come true. It's a constant headwind you're fighting against.
It is. Time is literally an asset that's melting away like an ice cube every day. So, how do we see all this stuff? The contract type, the strike price, the expiration, the premium. How do we see it all working together in the real world? Well, it's all organized in what's called an option chain. Think of it like the command center, the dashboard for any options trader. It lays out every available contract for stock and basically shows you what the market is thinking.
And this is where the rubber meets the road. Just look at this simplified chain here. We're looking at one expiration date, March 20th, 2026, and you can see a bunch of different contracts. Let's zero in on that first line, a call option with a $150 strike. The premium is $5.50. Now remember the multiplier. To buy one contract, you'd pay $550. That's the $550 premium times 100 shares. For that $550, you now control 100 shares that are worth, at that moment, $15,000. Now look down at the 155 call. Since the strike price is higher, it's less likely the stock will get there, so the premium is cheaper, only $275. The same logic works for the puts, just in reverse. The lower the strike, the cheaper the put. This table is the marketplace. It's where you pick your tool based on your prediction, your time frame, and how much risk you're willing to take.
And this just lays it all out, doesn't it? Understanding that 100-share multiplier, what the premium really is, the difference between a call and a put, and that push and pull between the strike price and the expiration date, that is the foundation. Every single complex, multi-leg option strategy you'll ever hear about is built using these simple, powerful Legos. Master these definitions and you've got the key to the whole kingdom.
So here's the bottom line. We've taken the machine apart. All the pieces are laid out on the table. We get the mechanics of leverage. We get the variables of price and time. The foundation is set. So the real question is, how do we apply this knowledge? How do we start assembling these pieces into actual strategies that can generate income, or hedge our risk, or give us those incredible asymmetrical returns? Well, that's where we're headed next.